Hi students, today we are going to discuss about the topic which is based on the process of photoelectric effect or photoelectric emission. So dear students, our topic is Einstein's explanation of photoelectric equation. Einstein explanation of photoelectric equation. This topic is a very important question. This lesson like a 40 percentage. This question only asks the 5 mark question. So this video gives only the introduction part. Generally you know in this lesson the radiation is as dual in nature. The one is wave, the other one is particle. That is nothing but like a photon. That is photon. Photons we can say that is it carry the light energy. It carry light energy. So in this topic, first of all, this video gives only like a introduction part. According to Einstein, here one metal is there, that is one metal surface. This is the another one metal surface. Actually the metal, I mean the material which is made up of atoms or molecules. So here take one atom. So you know in center of the atom having the nucleus, we know the orbit, that is like cell. First is K cells, that L cell, then M cells. For example, in this material which is taken as like an ferrous, means the ferrous atomic number is 26. So K cell having 2 electrons, then L cell having 8 number of electrons, the last one. Then M cell having 18 number of electrons. That is the formula is 2n square. Suppose the first orbit n equal to 1 means 2, second 8, that is 18. But just adding, see, we get the total atomic number is 26. So 2, 8, 16 only there. So 16 plus 8, 24, 24 plus 2, 26. So this last level is partially filled or balance level. So the electrons filled in the level is called valence electrons. So this 16 electron is called free electrons. This free electrons already you know, it is a direction is random, like a uncontrolled, moving in all part, randomly moving. Now see the number of free electrons which is randomly manner, that is inside the metal, this is moving in randomly. Dear students, see this metal, inside the number of free electrons are there, but photoelectric emission or photoelectric effect is not possible because of each metal surface having one potential barrier. This barrier which prevent the electrons leaving the metal surface, that is ஒவ்வொரு metal surfaceலையும் ஒரு potential barrier இருக்கும். That potential barrier is create, that is prevent the electrons leaving the metal surface. So due to thermionic emission or due to field emission or due to secondary or photoelectric emission, it is clearly taught with our students, that is in introduction student. In boys side Nimin, girls side Divya is clearly taught. So just to refer that thermionic emission, field emission, secondary emission, photoelectric emission. So apply that more kinetic energy, that time to potential barrier, that is this barrier is break and eject the electron from the metal surface. So this now this free electrons is inside like a freely moving, that is a uncontrolled moving. So first we need to increasing the energy of free electrons. So for that, by allowing the radiation, this is a allowing some radiation. So the radiation which is coming from any light source, example like sun whatever may be, we are considering the UV rays, that is electromagnetic waves. Already we know general part, that is radiation is dual in nature, that is behaving like wave or particle. Particle nothing but photons, that is we can carry the light energy. Photons is carry the light energy. Theory part, listen very carefully. See, the energy of photons, that is considering one photon, one free electrons. That is, when a photon of energy of a metal surface, it is completely absorbed by a single electron ejected from a metal surface. That is, considering one photon, it is ejecting in one free electron. So this is a UV rays considering one photon plus one free electron. At the same time, the energy of a single photon is splitting into two different ways. Two ways. So one part of the energy is used to liberate the electron. The another part is energy is imported to the electrons as kinetic energy. That is, the total energy is dividing into two parts. That is, total energy E is equal to one part of energy is used to liberate the electron, that is work function W. The other form is it is imported to the electrons as kinetic energy, that is half mv square. Listen very carefully. The total energy of a single photon is ejecting from this, that is a passing from the metal surface, they ejecting a single electron. That time it is dividing into two parts. One is energy is used to liberate the electron. Second is the remaining part of energy is imported to the electron as kinetic energy. So liberate the electrons means like a work function. Define work function, that is the minimum amount of energy required to liberate an electrons from the metal surface is called work function. So this work function nothing but the symbol is in this lesson, that is pi. There is pi naught is the not pi, there is pi naught is the symbol of this work function plus the kinetic energy. See the diagram also, this is a incident, a single photon, it is ejecting one electron also. So this is a ejecting one single electron. This electron moving kinetic energy is half mv square. So generally what is the energy of each photon, that is E is according to Planck theory E equal to h nu, but Einstein theory E is equal to mc square, but taken as the energy of each photon equal to, that is E equal to h nu. So instead of E, replacing h nu is equal to pi naught plus half mv square. Put this is equation number 1. Dear students, listen very carefully. This is a second case. See, this is another one, not another one, so same only. The second case, that is, let us consider if we reduce the energy or intensity or frequency is reducing by upcoming the radiation. So this is a radiation, incident radiation. That time we are reducing the energy or intensity or frequency. So this is energy of each photon is h nu. If reducing means low frequency, low means already that is a threshold frequency. It is nothing but there is a minimum frequency, there is a no photoelectric emission is applying, it is acting. So hv naught, this nu naught is equal to there is a threshold frequency. So if you are reducing the frequency level, that is h nu naught is there, means that time the electrons are emitted but there is no kinetic energy. That means ejecting electron is happen, but this electron is from the metal surface, the electron is not moving from the outside, so the kinetic energy of this electron is zero, but work is done. See, listen very carefully. Work is done but kinetic energy is zero, so the total part only work only done. So that is the metal plate and the electrons வெளியே வந்துடும், பட் வெளியில் வந்துட்டு மூவ் ஆகி எலக்ட்ரான்ஸ் வெளியே போகாது. ஸோ கைனட்டிக் எனர்ஜி இஸ் ஜீரோ பிகாஸ் ஆஃப் லோ ஃப்ரீக்வன்சி. Dear students, suppose reducing the frequency level, that time the energy of each photon is h nu naught. That time electrons are emitting but there is zero kinetic energy, so the total is only work is done, so the total kinetic energy is zero. So the equation is energy of each photon E equal to this one, that is E instead of E, that is the energy is h nu naught, that is low frequency. H nu naught is equal to work only done but kinetic energy is equal to zero, so half mv square is equal to zero. So h nu naught is equal to only pi naught. Put equation number 2. Then substituting 2 in equation 1. So instead of equation number 1, that is pi naught is replacing h nu naught, we get h nu is equal to pi naught replacing h nu naught plus half mv square. Actually this equation is known as Einstein's photoelectric equation. This equation is Einstein's photoelectric equation. Dear students, suppose there is no loss of energy, no loss of energy during emission time. That means inside the free electrons, by using collision, that time there is no loss of energy during photoelectric emission. That time the velocity should be maximum. So velocity should be maximum means automatically you know the kinetic energy is also maximum. So kinetic energy is also maximum, that is maximum velocity half m v square instead of put v max square, that is kinetic energy is equal to half m v square maximum, this is maximum kinetic energy. So substituting in, this is also like one special case. So substituting in equation 1 we know that is h nu is equal to pi naught plus half mv square. So substituting, instead of half mv square is like a maximum, we get that is h nu is equal to pi 0 plus half mv square, that is k max, this maximum time. So k max, that is kinetic energy maximum, is equal to h nu minus pi naught. Listen carefully. So the graphical representation of Einstein's photoelectric equation. So the graph is plotted between maximum kinetic energy and frequency. So frequency is plotted in x-axis, that is frequency, and maximum kinetic energy is plotted in y-axis, that is k maximum. See, this graph is plotted between maximum kinetic energy and frequency of incident light. First of all, initially when the frequencies increases, that time only kinetic energy is also increases. It is a slowly, the graph is like a straight line only, but it is slightly only rising. So like that will come. That means up to this much, that is nu naught. Nu naught, you know, that is a threshold frequency. Up to threshold frequency like that much, there is no free electrons is moving in kinetic energy. Up to threshold frequency, the kinetic energy is level is 0. After the threshold frequency nothing but like a minimum frequency. So the when the frequency is increases, the ejected electrons kinetic energy is also increases. So this is the graph is like a straight line. So up to this much, that is a new means that is a frequency, high frequency. Draw the negative axis means like that. Up to this much, the energy of each photon is h nu naught. So this is a maximum range, that is like a saturation current is producing like that. So up to this much, the energy of each photon is total energy, that is h nu. This is threshold frequency range, that is h nu naught. This is h nu. This is one metal. After this experiment did the Einstein, then it is verified. Another one scientist Millingen, he found that different metal using potassium, sodium, lithium, the graph is like that. There is a actually result is he is found the slope is independent of the metal. So that is for each metal like a different slope, that is a different straight line. So for example, cesium means like that, then potassium means like that, then sodium means like that, slightly varying, then calcium means like that. So up to this much, the threshold frequency range, here up to this much, here up to this much, here up to this much, and so on. So after he found that the slope is independent of the metal. Okay, this is a very important question, my dear students. Study thoroughly. This is a very important question. Explain Einstein's photoelectric equation and also the explanation of photoelectric effect. It is a 4-point having already taught with the Divya or Nimin. Okay, similar topic. There is laws of, I think, Adul Chandran, not Nimin. This is a 5-point having the laws of photoelectric emission. Instead of that same point only, I will teach also. Okay.